Hello everybody. Today we start a very interesting and very difficult theme. We will show some difference in model behavior if we have some difference in statement. So, for example, this is total deformation with general version of statements, the most general. We have bonded connection for all parts. We have default mesh for all parts. We have some general linear material. And we have boundary conditions and loads like this. We have one force. It's a vertical force with 1000 of kilograms or 10,000 of newtons. We have three fixation here, here, and here. This full fixation, so we fix all degrees of freedom and we obtain something like that. We have 570 microns of deformation. We have about 240 megapascals of stress. We have maximum of stresses here on our cranck, and we in most cases can say that it's no matter how do we fix this base, in reason that those task was created only for analysis of this object of this cranck. So this base, those bolts and those pins are created only for better applying of forces, for better applying of statement and of boundary conditions, and to better describing behavior of this cranck. So we have, as we say, stresses, we have deformations. Deformations are fully symmetrical, stresses are fully symmetrical, and if we will take a look for behavior of only base, we also will see fully symmetrical behavior for all three types of degrees of freedom, for X, Y, and Z. Okay, but if we take a look here, we understand this that this cranck it's a part of bigger construction with a lot of cranck on every side. So it's maybe not really good if we doesn't have any deformations here and any deformations here, because it's not very truthful, it's not very physical type of deformation. So we can apply some different type of statements, boundary conditions, and let's take a look what it change in our results. So we have the same force, we have the same material, we have the same connection because we use one model, but we have several tasks with different statement and with different boundary conditions and with different behavior of our objects. As the second statement, second static structural task, differ from the first with suppressing one fixation. We have fixation here and delete or suppress fixation on this face. And we have 590 microns of deformation, so it's more than we have on the previous. Here we have 567, here we have 590. And stress, we also have maximum stress here, and stress almost not changed for our cranck. We see some difference in stresses, and we see that for the second variant we have more stresses here, and it's in a statement where we doesn't have fixation on this face. But in most cases, near our cranck and our cranck have almost original stress distribution. So let's take a look to other statement. Okay, we have fixed support here, and we change fixation from those sides. We change full fixation for all degrees of freedom to fixation of displacement with only 1 degree of freedom. It's y degree. So here all points, all nodes can move in x direction and can move, let's draw it, and can move in z direction, but can't move in this direction, in y direction. And if we take a look into our deformation, we'll see that we have 655 microns, so it's much more than on the first. I think it's about 10%, sorry, it's about 20% difference. And we have the same stress distribution for cranck with the same place with maximum, but we have a really different stress distribution from second variant and from first variant. And what we need also to understand, on first variant we have fully symmetrical deformation. On second variant we also have another but fully symmetrical deformation. And take a look to this deformation, and it will see that we have different distribution of deformation. But for this task, if we take a look, we will see that we doesn't have symmetrical deformation. We have some difference. We have see that this side try to deform, first of all. Second, we see that this deformation distribution are not symmetrical, and even stress distribution are not symmetrical for base, and we see some difference here, but this difference came from mesh, and this difference are not from the mesh. And also we see not fully symmetrical deformations on a base for all three types of directional deformations. Okay, let's try to change our statement to other way, and let's do it more symmetrical. We do displacement here with y direction fixed and all other free. We do the same here, y direction fixed and x and z free, but we can't solve this task in this manner in reasons that our geometry can move here and here as a rigid body. It can't move on a y direction, on vertical direction, but it can move in a plane. So we need to add some fixation point, and it change our deformation, not this fixation point, but those displacement, change to 750 microns of deformation, so it's much more deformable. And equivalent stress are almost the same here, but have also some additional place with a bigger stress here, in reasons that our base will be much more deformable than original first statement, when we have full fixation on all faces. And in reasons that we have geometry which contact with this one or contact with this one on a second variant of on a red variant, we have much more stress distribution here in those points. So this is what we see here. And if we take a look, probe here, it's almost the maximum, 230 megapascals, 240 megapascals. If we take a look on a first object, we also see some hot spots here, but the level of this hotspot are much less, 160, 170 megapascals. So it's not twice, but it's 1.5 ratio between this stress distribution and this statement, and this stress distribution and this statement. And we have and with this stress distribution and this statement. And we have bigger deformation, and it's also almost 1.5 times more. And the last type of statement, it's not to use displacement, because when we, let's choose this one, and do something like that, we see that our points moved, any point move in those directions and don't move in those directions. And that's why we have different stiffness distribution on this face than we can have on a real object. So we can also add another type of statement. Let's see result, and let's see that we have a deformation of all these points in any directions, but it's not very big. And what we do for this model behavior, we add two remote displacement on those sides, on those and those sides. On both displacement, we have fixed y direction on both. On this place, we fixed all type of translational degrees of freedom. We do it for not obtaining rigid movement of these bodies. On this, we have only y direction. And also we fixed some rotational degrees. On this side, we fixed rotation around y-axis, because it can't move like this. And we also add a fixation around the direction in reason to not obtain rotation as rigid body. On this side, we fixed only rotation around that direction. In all other, you can rotate as you want. And we obtain not fully symmetrical, but it's very close to symmetrical model of deformation. So it means that our type of fixation are almost physical. And we have, as we see here, a bigger level of stresses here, in reason that we have maximum deformation of base. We see a big stress distribution here near the round, as it will be on the previous version. And we see total deformation, and this total deformation are very close to this one. It's have difference less than 10%, but we see changing in character of deformation distribution. So what can we say from all this type of calculation? First of all, let's take a look to our cranck. Stress distribution here, stress distribution here, 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 and here. And as we say, for all type of statement. We have stress distribution, which are very similar one to each other for cranck, for object that we interested in. We have difference in base, but we have the same picture for the cranck. We have difference in deformation. Type of deformation of cranck by itself will be very close one to each other, but cranck plus base have different type of deformation. Some of these deformation are symmetrical, some of these are not symmetrical. And what I need to say, all type of fixation, all type of statement, all type of boundary conditions can be applied for analyzing real task. Also, I need to say that for sometimes the more physical will be version A, first version, with full fixation of those three faces. When it is, for example, if we have picture like this, we have this cranck and we have analogical here, and we have analogical here, and we have also analogical here, 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 and the list of this cranck, it's very wide number. In two directions. In reason that we have the same deformation here, this will be a symmetrical plane. And this will be symmetrical plane too. And if we have here some rib which will take our base on a place, we will have deformation like this. If we have situation where we have base here and we will not have the cranck here, we have cranck in big distance, for example 2-3 times of this length here, we will have deformation like this. So for different type of tasks, for different type of things that you want to solve and to find, you must understand that statement will be different. And the reason, what do you want from this calculation, you will need different statement. And some statement will not give any difference to you. For example, if you need only stress distribution for this cranck, all type of the statement are the same. If you need deformation of this pin, for example, you need to open a door which connected to this cranck, And if you have big deformation, you will not able to open or close this door. You need to do some type of statement which will be more physical to your situation, and you will not interested in situations that all this statement will give one stress distribution picture. It's not interesting to you because you need this deformation distribution. And this deformation distribution are vary depending on type of boundary conditions for the base. So there are no simple answer what type of boundary conditions you need in your task. You need to create more physical type of distribution. Which will be more physical, you will need to analyze and to research by yourself. Thanks. Hope see you later.